So we are looking at more examples on midpoint theorems, which is the theorem we just took. We have to calculate the length of a chord of a circle of radius 26 cm if the chord is 10 cm from the center of the circle. Calculate the length of a chord of a circle of radius 26 cm if the chord is 10 cm from the center of the circle. So look at the parameters given to us. We are given the radius of this circle as 26 cm. That's the radius here, 26. If the chord is 10 cm from the center of the circle, that's a distance. Let's use dm as a distance of a line drawn from the center of the circle to bisect the chord. So dm is equal to 10 cm. So we draw a circle and put our parameters in the circle. Draw a circle, put our parameters in the circle. So let's draw a circle. We'll have a circle here. This is the center of the circle. Draw the chord of that circle. Let's say chord AB. And we see that the radius, this is the center of the circle O. And the radius of the circle is 26 cm. The line drawn from the center of the circle here to this point is 26 cm. We draw that line, so this is 26. This is 26 cm. So we are told that the chord, the distance of that line from the center of the chord down to this point is 10 cm. If the chord is 10 cm from the center of the circle, so from this point to this point we have it as 10 cm. And we are told to calculate the length of the chord, so we don't know L. That is unknown. This is M. So if I take one part of that triangle, this is O, A, and M. This is O, A, M. OA is 26, so this is 26 cm. OM here is 10, so this is 10 cm. We're actually looking from A and B. We're looking at how we can find AB, the length of the chord. But we have to find AM first of all, AM to the midpoint here. So AM, which is the length of the chord here, is unknown. So, haven't gotten my triangle, the next thing I'll do is to attempt to use that triangle to solve. Let me bring my triangle here for clarity. So I have this as O, M, A, and L. So this is 10, this is 26, that's the radius. So if I use Pythagoras theorem, which says that the hypotenuse square is equals to opposite square plus adjacent square. So the hypotenuse here is 26. This is the hypotenuse. This is the opposite, and this is the adjacent. So we have hypotenuse square here as 26 square. What's the opposite here? 10 square plus L square. So I haven't done that. We can rearrange that to become L square is equals plus 10 square is equals to 26 square. So I have L square plus 100 is equals to 676. so that if 100 crosses the equality sign here, it becomes negative. So I have this positive here. L squared is equals to 676 minus 100. So in that case, I have L squared is equals to 576. To get L, I have that as square root of 576. So I have that L is equals to 24 cm. So we see that from our circle that we have initially, we had this as the center of the circle, CO, are called as AB. Just a rough sketch, and this is arrow here. So I haven't gotten that. We got this as M, that's distance from the center of the circle, that straight line there. So we are getting AM now. AM as 26, or rather AM as 24 cm. So to get AB, we know that AM here is equals to MB. So we simply multiply by 2. So that AB is equals to 2 times AM, which is 2 times 24 cm. That gives me 48 cm. So the length of the chord, the full length of the chord AB, length of the chord is 48 cm.